Good afternoon. My presentation will be in English because I need to train for my PhD examination. So, first of all, thank you very much to Antonio for this opportunity every year. Thanks to everyone for being here, okay? My presentation is about depth cameras. First of all, what is a depth camera? Depth camera is a kind of camera that capture objects depending on the light that they receive. You can see in this image the different brightness of the human, okay, of the person, and the different brightness of the chair or of the door, okay? With this technology, we can obtain information about the human movement. This kind of cameras started in the entertainment area in video games. For example, the kinetic camera from Xbox 360 is the same technology as this kind of camera. The use of this camera in video games decreased during the past years, but now it is increasing in the research area and in the assessment of kinematics. There are other motion capture systems, other kinematic tools. For example, Vicon system. Vicon system has high reliability, but the main problem is it is very expensive and the setup is very complex. The IMUs, or inertial measurement units, are optimal tools for functional tests, but there is a human interaction. We need to put something on the person, and we can lose time to do it. So depth cameras are cheap, are easy to use, the preparation is easy, but obviously we have some problems with some disadvantages. For example, it is recommended to validate each test with the camera before, and the quality of the measurement will depend on the quality of the light of the room or of the area of the lab, okay? What kind of information we can obtain from the depth camera? We have information about the displacement or movement, linear or angular, the time, and as indirect variables, the velocity and acceleration as other kinematic tools. There are a lot of papers, a lot of studies in the literature about depth cameras and its validation in different clinical populations. For example, in Parkinson's disease, in elderly people, in stroke survivor, and the recent publication in subacute and chronic low back pain. Okay, after the data processing, we obtain this virtual skeleton, okay, with all the joints extracted from the camera, okay, from the information from the camera. We can obtain information in the three axes, yaw, pitch, and roll. I will talk about the joints called neck and torso because it's the joints that means the movement of the trunk, okay, the movement of the low back, and my research work is focusing on that. In this video, you can see an example of the information that we have. This is the data that we have in the laptop, in our screen during the measurement. It's very useful because we have information in real time, okay, about the quality of the measurement. After the data processing, we obtain this graph, okay. This is the sit-to-stand test, very easy. In red is the pattern of movement extracted from the camera, and in blue is the pattern from the IMU, okay, in time and in the angular movement. This is the setup that we use. The distance between the camera and the patient is around 2.5 meters. We don't place the camera totally perpendicular to the patient. We use 45 degrees of orientation. And this last slide is about how we can interpret the data from the camera, okay, the analysis. In this example, we use the bending test, okay. This is a simple test. Please pick up the pen from the floor and stand up again. This is the same virtual skeleton as we saw before. After the data processing, okay, we obtain this information in the three axes, yaw, pitch, and roll. I will talk about the pitch axis, because pitch axis means the flexion or extension of the trunk, okay, of the trunk movement. And how can we interpret this information? We can see in the graph that during 30 seconds we can count every repetition and measure the movement and the performing time, okay, of the repetition, because we know that this part is the first position, the starting position, and every peak is the maximal flexion, trunk flexion performed by the patient, okay? So we can analyze easily this, the kinematics with this kind of technology. Thank you very much for your time, and I will